Hello everyone. In the previous session, we studied about the 555 timer and its pin diagram and functioning of the pins. Now, in this session, we'll study about a 555 timer as a monostable multivibrator. This is also called one-shot multivibrator. It is a pulse generating circuit in which the duration of each pulse is determined by the RC network connected externally. Now, this RC network will also determine the time duration for which the output will remain high. In the name itself, we have monostable, means it has only one stable state, that is low stable state or logic 0. So initially the circuit will be in stable state or the standby state. So now in this condition, the output of the timer will be approximately 0 or logic low level. So whenever the trigger pulse is applied externally, the output is forced to go high, which will almost be equal to VCC. So now this is the pin diagram of monostable multivibrator. This is the circuit configuration of the monostable multivibrator, that is in detail. Here you can see pin number 6 and 7 are short circuited. It is given in detail in the notes which I have written, and this is connected to VCC via the resistor RA, and pin number 7 is connected to ground via the capacitor. Since there is no external voltage, this control input is also connected to ground via the capacitor C1 of value 0.01 microfarad, and this pin number 4, that is reset, is connected to VCC. So now coming to the operation of the circuit, initially the output is low, meaning the circuit is in stable state. So now in stable state, this transistor Q1 is on and there is short circuit. The capacitor is short circuited to the ground. Upon application of negative trigger pulse to the pin number 2, the transistor Q1 is turned off. Meaning whenever we apply negative pulse, this output of the flip-flop will be 1, and so the transistor will be turned off, and here the short circuit across the capacitor is released, which will drive the output to high state. So whenever this output of the flip-flop is 1, the transistor Q1 is turned off and short circuit across the capacitor is released, and at the same time, because of the logic 1 output of flip-flop, the output of the timer is also high. So now in this circumstance, the capacitor C will charge up towards VCC through this resistor RA. So now whenever the voltage across the capacitor is equal to 2 by 3 VCC, the comparator 1 output switches from low state to high state, which in turn will change the output of the flip-flop to low state. So now the output of the flip-flop is also low, which means the output of the timer is also low. So now at the same time, the flip-flop turns the transistor. See, whenever it is low, this transistor Q1 it turns on, and now here in this situation, this capacitor, you can see here, it discharges rapidly through this transistor Q2 that is present here. So the output of this monostable multivibrator will remain in low state until the next trigger pulse is applied, and then the cycle repeats. So whenever output is 1, the capacitor should charge. You can see here, this is the output waveform. For the positive cycle of the output, the capacitor is charging, and whenever this output becomes low, the capacitor discharges rapidly in this path. So this is the discharging. It rapidly discharges. While charging, it gradually charges. The maximum value for which the capacitor will charge is 2 by 3 VCC. and this is the trigger input that we are applying. T is the time period, T off plus T on, and this is about the operation of the monostable multivibrator. And the pulse width of the trigger input should be smaller than that of the expected output waveform. This is the important note that we are supposed to make with respect to monostable multivibrator. And the trigger pulse that is applied as the input should be negative going input signal, and the amplitude of it should be larger than 1 by 3 VCC. And this is the formula for the time duration for which the output remains high, that is given by Tp equal to 1.1 Ra into C in seconds, where Ra is in ohm and C is in farad. Once triggered, the circuit's output will remain in high state until the set time Tp elapses. The output will not change even if the trigger input is applied during this time interval. So this is the another circuit diagram with wave shaping network to prevent positive pulse edge triggering. So at the positive edge of the pulse, there should not be any trigger present. So this is the modification of the monostable multivibrator. Here we have introduced a wave shaping network which consists of C2 capacitor and resistor R and diode D, and here we have a decoupling capacitor C3 also. So here you can see the circuit can be reset during this time interval by applying a negative pulse to the reset terminal. This is already told. To eliminate, this is the important point, to eliminate unwanted voltage spikes in the output waveform, decoupling capacitor, you can see here, the decoupling capacitor C, it eliminates the unwanted waveform which has spikes in it. So in order to prevent any mistriggering, this circuit is itself for avoiding the spikes, unwanted spikes that is present in the waveform. So only so much is enough for this circuitry. That is very important. You are supposed to write it. So the part of the circuitry which consists of R1, R, C2 and D will prevent the mistriggering of the monostable multivibrator. So this will avoid the mistriggering of the circuit, meaning which gives a shape to the waveform, and here it avoids the unwanted spikes, this capacitor. That is why this C2, C3 is introduced. So this is about the monostable multivibrator, and you have one problem to solve. It is very simple, just substitution of the values that is given. Just try. And about the astable multivibrator also, I shared you the link. So here we complete the module 5. Next we'll start off with the module 2. Thank you.